Hello, so in this video we're going to go through question 7 here, so let's give it a read and see what we can do. We'll be using our CAS to answer this question. You could do it by hand, but I want to use the CAS. It says, the position x meters at time t seconds where t is greater than or equal to 0 of a particle moving in a straight line is given by x is equal to t squared minus 7t plus 10. When does its velocity equal 0? When does its velocity equal 0? Okay, so let's dive straight into it. So we're dealing with A, and what we have to do here is find the velocity. We know that the way that we find the velocity is by differentiating our position equation, so dx dt, and we can do this on our CAS. So let's go through the necessary skills we would need on our CAS to do this. So the first thing I would do is just define my position equation. So I would go x of t, and then go control this, then go t squared minus 7t plus 10, like that. Once I've done that, the next thing that I would do is, I'm actually going to do more than one step here. I'm going to say that my velocity, and I'm actually going to define it. Control this is going to be equal to shift minus differentiate with respect to x, with respect to t, x of t. So you got to be careful here and do that. So that means my velocity, v of t, is going to be that. So let's write that down. 2t minus 7. Now it says, when does its velocity equal 0? So what I'm going to have to do now is take my velocity, set it equal to 0, and solve for t. So let's see what happens when we do that. I'm going to come over here and I'm going to go menu, algebra, solve. I'm going to go v of t is equal to 0 for the t value, and I'm going to get 7 on 2, which is the same as 3.5. So what I'm going to get here is that t is equal to 3.5. Perfect, and that's it. It says, when does it equal when does its velocity equal 0? It equals 0 at this point. Now, it's important that you actually know what's happening here and you're not just blindly reading the question. You know that this is when a stationary point is occurring. You know that this is a stationary point. So it's not moving here. It's instantaneously at rest. That's what you know. All right, let's keep on moving. Let's go on to part B now. So come over here, grab the red again, B. We now need to find its acceleration at this time. Okay, so now we have to deal with acceleration. The way that we find acceleration is by differentiating our velocity equation with respect to time. So let's come over here. Let's come here. What I'm going to do is and I'll do this in one step again. A of t is going to be equal to control this to get the correct equal to signs to define, shift minus differentiating with respect to t, and then this last thing right here will be my v of t, because I'm differentiating velocity to get my acceleration. So that means acceleration will be 2. So I'll come over here, this will be 2, therefore 2 meters a second squared at all times. So the fact that my equation is just a constant, that means that when t is equal to 3.5, my acceleration will be 2, because it's always going to be 2. I have a constant acceleration through this entire particle moving. The acceleration's always going to be 2. And also take note of the fact that acceleration does have that direction to it as well. It can be positive or negative. So this is a positive 2 here, which is important. All right, let's keep on moving now. So I found its acceleration at this time. I now need to find the distance traveled in the first 5 seconds. So let's come over here. Let's go to C, where we're finding the distance in the first 5 seconds. Now I feel that many people would just do this. They would say, well, I'm finding the position after 5 seconds. Let's go x of 5. They would come here. What's my position at x of 5? It's going to be 0. Well, that's weird. Does that mean I've traveled 0 distance? What does that mean? Well, to figure out how much distance you've traveled, you have to figure out where you're starting from. That makes sense, doesn't it? Yeah, otherwise, you don't know. You've got a position 0. Yeah, but where did you start from? Have you stopped anywhere? All those really basic logical questions you have to ask ourselves. So let's draw ourselves a nice little line here. Let's try that again. Like that. We'll put 0 in the middle. Now, where am I starting from? Where am I starting from? We know that we can figure out where we're starting from by going, what is x of 0? So in other words, you start when t is equal to 0. So x of 0 is going to be what? X of 0. Whoa, that's not how you do it. X of 0. There we go. 10. So that means I'm starting at 10. This is my starting point. This is where I'm starting. Start here. I also know that I have a stationary point. My stationary point occurs when t is equal to 3.5. Now, 3.5 is a smaller number than when t was equal to 5, right? So I stop before I get to this 5. So I need to consider that. So let's come over here. Oh, we actually have to figure out where t of 3.5 is. So what's the position of that? So I'm going to have to go, what is x of 3.5? Otherwise, I'm not going to know where to stop. So this was 10. Let's come here. Let's come here. X of 3.5. It's going to be negative 2.25. So I'm going to come here. Negative 2.25. So this was my start point. Then I'm going to have a stationary point here. A stat point. That occurs when t equals 3.5. And then I finish up at t equals, at 5 seconds at 0. So here is where I end, which is t is equal to 5. And that's occurring at 0. So that means this is what it looks like. If I was to grab another color here, let's go brown. I'm going to go this way. Then I'm going to stop. Then I'm going to come around. Let me just tidy this up a bit. This was negative 2.25. So you can see how important this is. We're starting here, we're stopping here, and then we're figuring out how far we'll travel in the first 5 seconds. So this is where we are the first 5 seconds. This is what our graph looks like, or this is what the path looks like. So if I now want to figure out the distance traveled, how would I do this? Well, from 10 to 0, that's 10. From 0 to negative 2.5, that's 2.25 distance. And then from negative 2.25 back to 0, that's another 2.25. So notice that I'm not including the negatives here because I just want the total distance. So once all is said and done here, this is going to be 14.5 meters. And that's going to be my answer. So let's highlight that. That is how far I've traveled. And notice how important using the graph was to get that. Okay, let's come now to D. Part D. Now, what did it say? I can't even remember. It says, when does its velocity equal negative 2 meters a second, and what's its position at this time? So what I'm going to do here is I'm dealing with my velocity. So let's get out my orange. So I'm going to go, what's v of t when it's equal to negative 2? So I'm trying to find what my t is equal to for that point. So I'm going to come to my trusty CAS here. I'm going to go menu, I'm going to go algebra, solve. What is v of t when it's equal to negative 2? And I'm solving that for t. It's going to be 5.5 on 2, which is 2.5. So that means I come here, t is equal to 2.5. But remember, it also said it wants the position at which this occurs. So I'm going to have to now say, well, what is x of 2.5 to find the position for which my velocity is negative 2. There are so many words. There are so many words to say. So what is x of 2.5? It's going to be negative 1.25. So negative 1.25. So when it says at what position is this velocity negative 2, the answer would be 1.25 meters to the left of the origin. And that's going to be your answer there. Okay, now that's the end of the question, but I actually want to spend some time talking about something now, which I think is very important, and I think what some people will be confused about. And this is actually the third time I've recorded this video because I keep tripping over my words at this point. So excuse me if I do trip over my words again. Please come talk to me if you need any more clarification on this. But what I imagine some people are going to be a bit confused about is, how do I have positive acceleration and a negative velocity? How on earth does that work? How can I have positive acceleration but negative velocity? And it's quite clear by looking at this that, you know, from here to here, I have negative velocity because I'm going this way. So how can I be going this way yet have acceleration that's going this way? It just boggles the mind. So let's just think about this for a moment and see if we can make any sense out of it. What I want to begin by doing is just by considering what's actually happening with my velocity as I go along this line. What's happening with my velocity? Am I speeding up? Am I slowing down? What's happening? Because we know that my acceleration is the difference in my velocity, the change in my velocity over time. So if we consider what's happening with our velocity, that will help us with our answer here. All right, let me just move this so we can see it. I might have to do that a bit. Still can't do it. Come on, computer. All right, good. So we're going to start at t is equal to 0. So that's going to be, what is x? No, sorry, what is v of 0? Because I'm finding the velocity at 0. The velocity is going to be -7. So that's -7 in this direction. It's -7 in that direction. And actually, just so this doesn't keep happening, let me just move this like that. How good is technology? All right, so that's the velocity that way. It's going -7 that way. So it's pretty, you know, I'm going quite quickly this way. What happens when v is equal to 0.5? Now it's -6. So do you notice how it's less, I'm going less quick in the negative direction now. I'm slowing down. Because my number is getting bigger, my velocity is less in the negative direction. It's slowing down. When I go v of 1, it's even less, -5. I'm going even slower. So do you notice how that my velocity, it's slowing down. My velocity is slowing down as I go along. And if I keep on going here, let's go v of 1.5 now. It's -4. And I just want you to see what happens as I continue to increase my time. Look at what's happening to my velocity. So next would be v of 2, -3. V of 2.5, my velocity is slowing down. And when I say that, when I say it's slowing down, my number is getting bigger. It's getting less, it's going less quickly. It's going less quickly this way, less quickly that way. That's what it means. All right, let's go v of 3. V of 3. What if I went v of 3.5? Well, we know what's going to happen at v of 3.5. It stops. I am stationary at that point. So if we can picture what this is happening here, I want you to follow my cursor here. I start off pretty quick, then I slow down. I slow down. I slow down. Then I stop. So I started off quickly, but then I slow down. Then I stop. So what's happening with my velocity? It's slowing down. My velocity, it's slowing down. But then what happens when I go the other way now? So once I go past my stationary point, what's v of 4? That's 1. What's v of 5? 3. What's v of 3? Oh, sorry. I knew I was going to do that. 6 comes after 5, just so you know. V of 6 is 5. V of 7 is 7. V of 8. My velocity is speeding up once I've gone past my stationary point. It gets quicker. So what's happening with my velocity all this time is that I have this positive acceleration with it. So even though I'm going this way, it's got this positive acceleration, which is causing the velocity to slow down. And then once I get to the other side, the acceleration is meaning my velocity is increasing. Kind of strange, kind of weird. Hopefully that kind of makes sense. Again, I think I've said previously, if you've done physics, I imagine that this makes far more sense. This is, for my taste, far too much like physics and science. You know, with maths, you don't normally talk about practical things like this. Normally it's all just abstract, but we're trying to really wrap our heads around some pretty tangible things here. Hopefully that makes sense. All the answers are there anyway, but if you just wanted a bit more explanation, I think I explained that rather well, but if you are still confused, come speak to me. That took 15 minutes. I will see you in the next video.